Hey guys, this is number 57. Okay, so first, if I think that doing the derivative of either the top or the bottom is going to be a little tricky, then I always write it off to the side. So on the bottom, the derivative of 4 root x is the same as doing the derivative of 4x to the 1/2, and that will be 2x to the negative 1/2, which I will rewrite as 2 over the square root of x. So when I need the derivative of the bottom, this is what I'm going to write there. Okay, so using the quotient rule, low d high, high d low, draw the line and square below. So low is 4 root x. D high is the derivative of e to the x, minus high, which is e to the x. D low is what we found over here, and I'm going to write it 2 over square root of x. But honestly, if you got good at it, you could squish that together as one term right away. Draw the line and square below. Well, when I square the bottom here, you square the 4 and you square the root of x. So 4 squared is 16. Square root of x squared would be just x. Okay, so that's what you think the answer is initially, but then of course you look at the answer and nope. So hopefully after looking at my last example, you know that you can't leave it a fraction within a fraction. So the problem is this guy. So to get rid of that, we're going to multiply all 3 terms. I say all 3 terms, it's not technically right, but whatever. We're going to multiply everything by the square root of x. Got to multiply this guy by root x, and this guy by root x, and this guy by root x. What you're really doing is multiplying by the square root of x over the square root of x, which is why it's legal, because that has a value of 1. But in the numerator, I end up distributing that square root of x to both terms. Shortcut is, you end up multiplying square root of x by all 3 things. Okay, so here we go. What does that do? Well, the whole point of it was it makes these cancel. So now I don't have a fraction within a fraction. So how does it simplify? This big bunch of junk there, we've got a 4 out front, and I have an e to the x, and I have a square root of x times another square root of x, which is just x. And it doesn't matter what order we wrote those 3 things in, okay? Minus, this is just 2 e to the x. And on the bottom, I have 16 x to the, what is that? Well, it's x to the first and x to the 1/2. When you multiply, you add. So it's 1 plus a half, 1 1/2, or 3 halves. And you think, yay, look at me, I'm so smart, I think I've got it. Nope. Still not the answer that's in the back of the book, because can you notice that everything can be divided by 2? And the numerator also has an e to the x. So go a little bit further. Factor out from the numerator, factor out a 2, and factor out an e to the x. And what's left over is 2x minus 1. And the only thing that really did for us, since the denominator does not have an e to the x, the only thing that allows me to do is cancel the 2 and the 16. Remember, you can only cancel in multiplication, not in addition or subtraction. So I couldn't cancel while we were here in that subtraction, but now that it's multiplication, I can cancel this 2 and this 16. Divide them both by 2, we get a 1 and an 8. And that gives me my final answer of e to the x times 2x minus 1 over 8x to the 3/2 power. This is crazy stuff, right? Okay, so that was, I don't even remember what number that was. That was 57. And now I'm going to move on to another one, but I'll hit pause because I don't know which one's next. Pause. Okay, so the next one, and maybe the last one for tonight, 81. So when you first see this problem and you know you have to do a quotient rule, you have to ask yourself, should I leave the 8 factored out the way they have it here, okay? Or should I distribute? Well, that all comes down to which one would you rather do the derivative of? Would you rather do the derivative of this, which to me is maybe a little bit confusing and not quite sure, or would you rather do the derivative of this? So I say distribute it and do the derivative of the second version. But Honestly, it doesn't matter. Of course, there's more than one way to do the problem. So I think it's easier for you guys while you're new to distribute. And now we're going to do our quotient rule. So the derivative will be low, which is e to the x, d high, derivative of the top is 8, minus high, and since there's more than one term, you have to have parentheses. Okay? And let's see, low, d high, high, d low, e to the x, draw the line and square below. Okay, so that's the first step. Okay, so now if you'll notice, there's an e to the x in all three spots. So that's kind of your clue that you'll want to factor it out. It's true you could visualize the e to the x here, and you could distribute a negative e to the x, but it's going to take you longer. So try to get used to seeing this because it happens a lot. There's an e to the x here, there's an e to the x here, there's an e to the x here. So we're going to factor out so that we can cancel. So I'm going to factor out an e to the x. When I do that, take away an e to the x from this term, and you're left with an 8, minus, if I take the e to the x away from this term, the e to the x goes away, but I still have the parentheses and 8x minus 16. Okay, and in the denominator, I have e to the x squared. So the whole point in that was now these e to the x's can cancel. One of these and one of these, they're gone. So what's left? Way up here, my derivative now, what do I have left? I have 8. I'm going to distribute this negative, minus 8x, and plus 16, because I distributed the negative. And on the bottom, I have e to the x. Okay, combine like terms, and my derivative will be, let's see, negative 8x plus 24, all over e to the x. Okay, so that's if they just asked for the derivative, we'd be done. Now go back and read the question again, and you'll see you got to go a little bit further. So the problem asks, when does g of x have a horizontal tangent? Well, hopefully you wrote immediately a horizontal tangent is when the derivative is 0. Well, the derivative is a fraction. So when does a fraction equal 0? A fraction is 0 when the top is 0. So 0 on top is okay. That still equals 0. 0 on the bottom, no bueno. That's undefined. So we want to know when this equals 0, and it'll equal 0 when the top equals 0. So when does negative 8x plus 24 equal 0? Solve that, and you get that when x is 3. Now you think, oh, for sure I'm finished with this problem. But no, because if you read the directions again, it says to find the points where there's a horizontal tangent. So basically we have the x coordinate, and they still want the y coordinate. So now I have to find the original problem so that I can plug this x into the original problem to get the y coordinate. So here's the original problem, and now I need to plug in the 3 so that I can find the y coordinate that goes with it. Well, when you plug in a 3 here and here, no big deal. 3 minus 2 is 1, and 1 times 8 is 8. And on the bottom, e to the third is, well, e to the third. Yep, they love those crazy answers. So it looks weird, but that is your answer. So the horizontal tangent occurs at 3, 8 over e cubed. And that weird answer is the answer. So hope you're doing okay. I know they're not the easiest problems, but if you study as you go, we really only came across 2 issues you guys are having, okay? The 2 issues are, if you have a fraction in your final answer, it's all about simplifying. If you have a fraction and you have more than one term, okay, if one of the terms has a fraction with a variable, then get a common denominator. The other issue is when you have a fraction within a fraction, okay, then you got to make sure if you have a fraction within a bigger fraction, you got to get rid of that fraction within a fraction. There's just 2 things, but I know it is confusing. Good luck. Hope you're doing okay.